In this video, we're going to talk about key features of quadratic functions. So by the end of this video, you should be able to answer these essential questions. What is the shape of a parabola? What are the key features of a quadratic function? What is the difference between a maximum and a minimum? And what are other names for x-intercepts? So looking at our notes, it says a quadratic equation. Our quadratic equations have three different equations, and the shape of a quadratic function is a parabola. So a parabola is a U-shaped graph. Okay, it can be a U or it can be an upside down U-shaped, but it is U-shaped. Okay, so we have our three different forms. In videos following this, we'll go more in depth with these, but we have our standard form, which looks like this, our vertex form, which looks like this, and our factored form, which looks like this. Each form is important to find a different key feature, and that's what the videos coming up will tell you. So let's look at our key features. So first, we have our x-intercepts, our roots, our solutions, and our zeros. All four of these words mean the same thing. Okay, and this is asking you when the function crosses the x-axis. So if we look at our graph, this right here is the x-axis. Our function is crossing it 2 times. Those are our x-intercepts. Those are our roots. Those are our solutions. Those are our zeros. With quadratic functions, you can cross the graph 2 times. You can touch it 1 time, or it doesn't have to cross at all. Looking at the next key feature is the y-intercept. The y-intercept is where the graph crosses the y-axis. So the y-axis is this axis right here. And notice that our graph is crossing it right here, and it only has one y-intercept, and it will only ever have one y-intercept. So let's go ahead and label our axes, or our axes. So there's y, there's x. Okay. So looking at the next one, it's talking about the vertex. The vertex is the turning point of the parabola, which is the highest or the lowest point on the function. So if we look here, this is our vertex. The vertex in this picture is the lowest point on the graph because nothing goes below it. So when it's the lowest point on the graph, we call that a minimum. When it is the highest point on the graph, we call that a maximum. So in our picture here, we have a minimum or a min. Okay, now the vertex is going to be labeled as h, k. And that comes from our vertex form up here, which again, we'll go more in depth later. But we need that to help us find our axis of symmetry. So the axis of symmetry is an imaginary line that passes through the vertex. It's an imaginary line that passes through the vertex. So that is this dotted line. It is not part of the graph, but it is a line that cuts through the vertex. And notice when it cuts through the vertex, everything on this side lines up with everything on this side. Okay, so the equation for the axis of symmetry is x equals, and it is the x value of the vertex, which is h. It always has to have an x equals, so make sure you write that. Then, our last two things is the domain and the range. The domain is going to be the same for every quadratic function, and it's all possible x values, but in this case, the domain is always going to be all real numbers. Okay, it will always be this, all real numbers. Then our range is all possible y values. The y values are going to depend based on if the graph is opening up or opening down. So when you have a parabola that opens up, and that is h, k, then your range is going to be y is greater than or equal to k. But when you have a parabola that opens down, like this, then your range is y is less than or equal to k. And it's because all the k values are less than the y value, okay? Or all the y values are less than that k value. So here we go. We're going to analyze this picture, identify the key features. So here we go, x-intercepts. X-intercepts is where it's crossing the x-axis. So we have -3 and we have 1. So for the purpose of our assignment, we're going to write -3, 0, that's for the first one, comma our second one, which is 1, 0. Okay? When it says x-intercepts, it does want the point, or it does want the x-intercept written as a point. But when it says zeros or roots, then you can list it out. So we have x equals -3, 1. Okay, so that is to help you with your assignment. Then the y-intercept. The y-intercept is where it's crossing the y-axis. So it's crossing at -3. So this would be 0, -3. The vertex is the lowest or highest point. It's the turning point. That's right here. So that x value is at -1 and the y value is at -4. So then we want to know, is this a maximum or a minimum? This is a minimum. It is a low point on the graph. So the next one comes for our axis of symmetry. That is just going to be x equals the x value of our vertex, which is -1. So again, the axis of symmetry is a line that is not part of the graph, but it cuts your parabola in half. Everything on the left matches everything on the right. So let me zoom in. If you have a point that is 2 spaces away from the axis of symmetry on the left side, then you also have a point that's 2 spaces away on the right side. Okay? Same thing goes here. If I have a point that's 1 space away on the right, then if I go 1 space away on the left, I also have a point. So it kind of helps you figure out where the points are if you don't have a whole bunch. Same thing over here. So I have a point on the right that's 1, 2, 3 spaces. So if I go 1, 2, 3 spaces, I have another point on the graph. Okay. And then the last thing we're going to talk about here is the domain. That's just going to be all real numbers. Every single time we talk about domain, it's going to be all real numbers. Okay, looking at the next one. So here we go. If you want to pause the video and try to find these on your own, please go ahead and do so. So here we go. We are starting with the x-intercept. So this only has one x-intercept. It is only touching the graph or x-axis, the x-axis one time. So that x-intercept would be 1, 0. The roots, the zeros, would be just x equals 1. Then we want the y-intercept. So the y-intercept, it's crossing right here at -2. So to write that as a point, that would be 0, -2. Our vertex, okay, our vertex happens to be the same point as our x-intercept. That can happen, 1, 0, and this is a maximum. Okay, the axis of symmetry. So the axis of symmetry is x equals, and it's the x value of the vertex, which is x equals 1. Okay, our domain, all real numbers. And on this one, we do have the range. So the range, let's see, if we're looking at it, y is less than or equal to that maximum value of 0. Okay, let's go back and write the range on the previous one since we didn't. That way we have it here. So this one, because it opens up, y is greater than or equal to that minimum value of -4. Okay, now on this one, we do want to complete the table. So let's look at this. We have our x values and we want the y values that correspond with it. So we're just going to go and look for them on the graph. So at -1, if we look, let me zoom in. Here's -1 as an x value, so I'm looking to see where it hits the graph. It kind of goes off the grid, so we'll come back to that one. At 0, well, here's 0. Where does it hit the graph? It hits at -2. So we're going to go ahead and write that in. That was our y-intercept. Then we look at 1. At 1, it's hitting our x-axis. That was our vertex and our x-intercept. So we have 1, 0. At 2, let's look at 2. So here's 2. We go down to see where it's hitting the graph. And it's hitting the graph right there at -2. So one thing that I do want you to see is that once you get to a point in the graph where the numbers start matching on either side of it, that's how you know you found the vertex. Okay? Then at 3, if we look, here's 3, we go down and that's not on the graph. So what we can do is we can use the equation that we were given and plug in -1 and plug in 3 to see the y values. So that's what we're going to do. We're going to start by plugging in -1. So we're going to find f of -1. What that means is we are going to plug in a -1 in for every x. It is really important that you put the -1 inside parentheses, and when you're squaring it like we did here, you're squaring it on the outside of the parentheses. Okay, let me make this fit inside that little area. There we go. Then we're going to use order of operations. So order of operations say we take care of exponents first. So -1 to the second power is -1 times -1, which is just 1. Okay, so we're going to take care of that first. Then we're going to multiply. -2 times 1 is -2. 4 times -1 is a -4 minus 2. And this would give us a -8. So that is the y value at -1, which if the pattern holds true, it should be the y value at 3, but let's double check. So now we're going to repeat this exact same process, but this time we're going to plug in 3. So again, square first. So 3 squared is 9 plus 4 times 3 minus 2. Then we can multiply -18 plus 12 minus 2. -18 plus 12 is a -6. Minus 2 is also a -8, which is what we assumed it would be because, again, it is 2 spaces away from the vertex. So 2 spaces the other way should be the same value. Okay, so that is the end of this lesson. If you have any questions, please make sure you write them down and you don't forget to ask in class.